Hi, welcome to my video on Extra Problems Part 3. And this is in the unit on logs and natural logarithms. This video I'm going to again do more problems or solve more equations. Let's do number 1. Express y as a function of x. That means I have to get an equation with y on the left and x on the right. Okay, let's look at, we got logs on both sides, so I have to bring each side to a log, or I have to have logs on one side and number on the other. I look right here and I see this is the same base of 2. I look here and I see they're different bases, so I would have to simplify the log of 3 to the x base 3. That becomes an x. The log of 125 when the base is 5, so 5 cubed is 125. So the right side becomes x minus 3, and the left side got a log base 2, so because we're adding, we can multiply 7 times y plus 1. Now we, instead of equation with logs on both sides, this right side simplified, so now we have the log on one side. So now we're going to go the log of base exponent number, convert that to base x, that's the log, convert that to base exponent number and exponential. So we have base is 2, the exponent is x minus 3, and the number is 7y plus 1. So we have to solve this for y. So let's reverse it and put y on this side and 2 to the power of x minus 3 on the right side. So we have to solve it for y. So we go 7 times y plus 7 equals 2x minus 3. We're solving for y, so we have y on the left, so that's 2x minus 3 minus 7. And we divide, have to divide by 7. So we divide each term by 7. So that cancels, and we get y equals, so 2 to the x minus 3 divided by 7 is the same as 1 over 7 times 2 to the x minus 3 minus 1. So that's, we're dividing by 7, so it's 1 over 7. So I could put this in brackets or just leave the multiplication sign. I can do that if I want. So it's 1/7 times 2 to the x minus 3 minus 1. And that's expressing this log equation, making y as a function of x. So again, I try to find extra problems to help you think. And another one, solve for x as an integer. So we want x as an integer. So the log of x base 2 plus the log of 4, the log of x base 4 equals 9. So look and say, well, these are the sum of logs is the log of the product. That's only true if the bases are, both of them are base 4s or both of them may base 2s, but they're not base 4s. So this probably we can convert. We have the log of x base 2, we have x here, so probably if we, one idea that I came across when I seen the problem is that I would go 1 over the log of x base 4. So we move the x down. So that means probably what I should do is make this one x, the log of 2 base x, do the two of them. So that reciprocal, the x moves down, the 2 moves up, as in here. So both of them now have base, and that's equal to 9. So I said I have both bases. Because I have both bases, Then this is a 2, so I'll try to make this a 2. So there's 1 over the log 2 base x. And you change the 4 to a 2 squared. Equals 9. And we have 1 over log of x base 2 plus 1 over, and so that's to a power, so I go 2 log 2 base x, because the power goes in front of the log. Now we have the denominators the same, log 2 base x. This is log 2 base x, but your denominator, the LCD, is 2 log 2 base x. So that means I multiply this one by 2 over 2. So that gives me 2. 2 times 1 is 2. 2 log 2 base x plus 1 over 2 log 2 base x. So multiplying it by 2 gives me the same denominator. So this is the equivalent fraction. 2 divided by 2 brings it back to 1. That's equal to 9. And now I have the same basis. So 2 log 2 base x. And when I'm adding fraction, the common denominator, 2 plus 1 is 3. And now, because this is a fraction, I can make the 9 over 1 across multiply. So 2 times 9 is 18 log x base 2 equals 3 times 1 is 3. And we divide by 18. We get the log 2 base x equals 18. 1 over 18 is the same as 1 over 6. Now I have base exponent number. So this is the log, so I have x raised to the 1/6 equals 2. Base exponent number. So this is x to the 1/6, so I'm going to go 6 power. So if I raise this to the 6th power and raise this one to the 6th power, 1/6 times 6 is 1, x to the 1, and 2 to the 6 is 64. And if we do a check, we have log x base 2 plus log x base 4. X is 64. So 2 to the watt power gives you 64 is 6. 4 to the watt power gives you 64 is 3. And that adds up to 9. So again, oops, didn't mean to do this mark here. Converting these to the reciprocals, making both of these so the bases are the same, so I can work. So that was a good problem that I seen or came up with to help you think. Always keep thinking in math. Okay. This is, I got 6 here, but really it's problem 3. 6 on the previous page because I was going to do more problems. Oh, okay, that's okay. Now, solve for x exact value. Now I came across a different solving equation. These are exponentials. So notice I got a base 6 here and a base 2 here. So I have to somehow think this is 2 to the x plus 3. This is 2 to the x. So if I take, I can't add those. When you're adding exponentials, they got to be the same, so I can't add because they're not alike. So 2 to the x plus 3 is the same as 2 to the x times 2 to the 3. So as a result of this factoring, Again, we're doing reverse. Because this is the plus, I can do a multiplication of exponentials. So I see that 2 to the x is common. So if I take 2 to the x out of this expression, I get 2 cubed. And if I take 2 to the x out here, I get a 1. So this is 6, 2x minus 1 equals, and 2 cubed is 8 plus 1 is 9. Now I have 6, 2 to the x minus 1 equals 9 times 2 to the x. So because this is a multiplication exponential, now I can do the log of both sides. That will bring the exponent in front. I can do the log of a product. So this is 2x minus 1 goes in front of log 6. And because this is the log of a product, it becomes the sum of the logs. So 2 to the x minus 1 log 9 and 2 to the x, so this becomes x log 2. Again, these problems you have to be always thinking. So I have this one expanded out, product, the log of a product is sum of the logs, and put the power x in front, so that gives me a log 2 and a log 9. So now I multiply 2x minus 1 by log 6, so it's 2x log 6 minus log 6. Now I notice that I have an x here and an x here, so we group those together. So I have 2x log 6 minus x log 2. The x's are grouped together. And I have a log, bring the log 6 over, make it positive, plus log 9. Notice that x is common here, so I'll take the x out. So take the x out, I get 2 log 6 minus log 2. And write down the right side. So I divide by 2 log 6 minus log 2 on each side. It cancels, so I get x is equal to log 6 plus log 9 divided by 2 log 6 minus log 2. And so that's an exact answer, but let's tidy it up. The log of 6 plus the log of 9 is the log of the sum of two logs is the log of the product. So 6 9s are 54. And we have to take the 2 and raise it to 2, so that's just without doing, so that's log 6 squared minus log 2, so the 2 goes to the power. That gives me the log of 36, and we have a subtraction, we divide by 2, so that becomes a log of 18. Instead of keeping writing it out, I just took this, looked at it on the side, raised the 2, so that's the 36 divided by 2 is 18. So this answer, that could be the exact answer, or we can write it as the log of 54 base 18. Either one will do. We can have the log of 54 divided by the log of 18, or we can also call it the log of 54 when the base is 18. And if you take your calculator and divide this out, this is approximately, the log of 54 divided by the log of 18 is approximately 1.38. This is the exact answer. This is the answer that you want, or this one. But if you did an approximation and you took your 1.38 and subbed it in here, raise it to the 6th power after. So 2 times 1.38, subtract 1, raise it to the 6th power, will give you 23.4. And if you take your 1.38 and add on the 3 and raise 2 to that power, plus 2 to the 1.38, and work that out, you'll get 23.4. You can check it out yourselves with a calculator, but the exact answer is the log of 54 divided by the log of 18, or the log of 54 base 18. That's the exact answer. And notice the good problem. Notice I had to keep expanding until I got x's. I grouped my x's, take the x out, and now we can solve for x because we have x on both sides. We have to group the x's with the logs together to factor the x out. Again, excellent problems to help you think. Find x to the nearest thousandth. So we look around and we have a log on each side, but we can't make them, we can't say that this expression here equals this one because they're not the same bases. So we have log base 3. So 1 over 25 to the negative a half, that becomes, the negative makes it 25 to the half. So the negative flips the fraction to 25 to the half. The 25 to the half is the square root of 25, which is 5. So this becomes a 5. So that's partly simplified. Now, what do I have here? I have the log base 2 to the x divided by 8, but 8 is 2 cubed. So this is log 5 base 3. So this is the log 2 is the base. And because we're dividing, we subtract the exponents. So it's 2 raised to the x minus 3. So we have log 5 base 3 equals. And notice we have the base is here of 2. The base here is 2. That means that x minus 3, because we did a rule where we have a base. So this expression here has the same base as, if these two are the same, that it equals x. So that's 2 and that's 2. So this is the answer, x minus 3. Now we have a base, an exponent, and a number. So we could go this way and do the log, but that would be the long way to go. The best way to go is to take the log of 5 and divide it by the log of 3 equals x minus 3. So x is equal to the log of 5 divided by the log of 3 plus 3. So when you work that out, so I could go here, but the shorter way would be to take the log of 5 base 3, write as the log of 5 over the log of 3, move the 3 over, and then take your calculator and take the log of 5 divided by the log of 3, get an answer, and add on 3, and you get 4.465. 4.465. So if you take 4 to the 4.65, sub it in here, divide it 2 to that power, divide it by 8, and you'll get a decimal. So you take the log of this decimal, or whatever it comes out to be, divide it by the log of 2, and it should give you the same answer as what we have here. The log of 5 divided by the log of 3, 4.465. Again, a little bit different problem. So you could go this long way. This is the long way, base exponent number. But then if you go this way, you got to do the log of 3 to the x minus 3 to the x minus 3 equals log 5. So that's x minus 5 log 3 because the power goes in front. And so you get x minus 5. You divide by log 3. And then x is equal to, that's a 3 there, 3 there, 3 there. So the log of 5 divided by the log of 3 plus, that becomes a plus 3. So that's x minus 3 goes in front. And so this right here, this is the long way, doing the log of each side and working it out. The shortcut is to change the log of 5 base 3 to the log of 5 over log of 3, add on your 3, and then you get it right away. So either you can go this way to get to here, to get your decimal of 4.465, or take the shortcut. Your choice. Number 5, find x to the nearest 1,000. So x is here, so we could, there's a couple of ways to go. I could go log x base 5, and so this is the log of 74 divided by the log of 2, so that's the log x base 5, and that comes out to be, if you take the log of 74 and divide it by the log of 2, you get 6.209, and so base exponent number, so x comes out to be 21872.8, and so the answer to the nearest 1,000 is 22000, because that's ones, tens, 100,000, so it's 20,000. Or another way to do this one would be to, another option would be to go log x divided by log 2 equals log 74 divided by, I said log x divided by log 2, that's log x divided by log 5. Better be careful. And that's, so this one is the log of 74 divided by the log of 2. So to solve this for x, we cross multiply, so take a shortcut. So the log x is, so it's the log of 74 times the log of 5. So we cross multiply and get this, these two multiply, and we divide by log 2. So it's log 5 times log 74 divided by log 2. So the log of x, and this works out to be, when you work this out on the calculator, the log of 74 times the log of 5 divided by log of 2, that works out to be 4.340 when you round it off. And if so, what I do is the base is 10 understood. So the log x is in base 10, so I'm putting the 10 here. So that means your base is 10, your exponent is 4 to the 3.4 equals x, base exponent number. And so when you take 10 and raise it to the 4.3, you will get 10 raised to that power is 21877.6. And again, if we did it that way, the answer to the nearest 1,000 would be 22. So there's two options to do this one. You can, again, write this one out and work it this way, or you can work both of them out as a fraction, cross multiply, and then put this to the base 10, raise it to the exponent 10 to this exponent gives you x, and you got two ways to do it. Again, I have a variety of problems done and more examples, because the more examples you see, hopefully the more you'll see, because sometimes when you see it done, you say, oh, I remember that trick. And again, math is simple little tricks that you do with the skills that you've learned. And I hope you enjoyed my video. Click on the like button if you did, and click on the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.